Good morning, students. Can you hear me?
Yes, sir.
Okay. So this is the last class of the Smith chart, and today we'll see the double stub matching. Okay. So we'll utilize the previous concept as well. Okay, what we have seen for the single stub matching. Correct. So let us see. Okay. So like we have already got the idea from the single stub matching that we can uh, match the microwave circuits. Correct. So it was we have seen in the last class that open or short-handed stub could be connect at the location of the transmission line, and we can vary the location fine as well as the length. Correct. So we determine the D as well as L. Correct. And by this way we could manage the matching in the circuits. Correct. Now then like we already have the idea about this, that we can match the circuit with the single stub matching. So what is the need of the double stub matching? We need to understand first, and then we'll try to solve some of the problem with the double stub matching. Correct. So uh, the point is that it is really very difficult to build a variable length coaxial line with a constant characteristic impedance. This is one of the things actually uh, we cannot freely utilize this thing single stub concept, because when you are varying the length, okay, and you have to find some mechanism. Actually, I'll show you some of the example that how we are varying the length, but sometimes we are losing the z naught, and it's create a lot of problem. Correct. So the thing is how we can solve these problem actually. So this could be solved by the use of the two short circuited or open circuited stubs attached to the main line. Means instead of attaching single line, we'll attach this time the double stubs. But the thing is, this is at the fixed position. Like fixed position means between these two stubs, the distance between fixed. Correct. Okay. And these fixed arbitrary distance may be chosen as like lambda by 8, lambda by 16, 3 lambda by 8, like that. Okay. And this thing says further what we can do, we'll try to find it out mechanism that how we can adjust the length. Correct. However, it is difficult, but here we'll see that how we can do with this adjusting the length. Correct. Fine. So this is the thing actually. Now let us see the circuit diagram and then try to analyze over the Smith chart that how we will do over the Smith chart. Correct. So let us draw first a transmission line. So let's say this is a transmission line we have. Okay. And the characteristic impedance is R naught. Fine. Now we are going to connect two stubs actually. Okay. So later this is the load location. This is ZL. Fine. This is ZL. And now let us try to connect here these things, the steps. Okay, so we are going to do a short circuit here. Fine. Similarly here also you can do this is also a short circuit. Fine. And between these two stubs we are keeping a fixed distance which is d naught. Okay, now let us mention some of the variable over here, and let us start from this point. So this is, let's mark as a dash. Okay, this is, let's say, marks a dash. And one more thing I forgot to mention, the characteristic impedance of these stubs are same as the transmission line, which is r naught. Fine. Now the thing is, we can because these all the system is not connected in a parallel, so better to work in an admittance form. Fine. So let us define the admittance at the different locations. So first of all, this side, let us define as ys stand for the stub A. This is a normalized one. Correct. Okay. And from this side, let us say ysb bar. Okay. Admittance of the second step. Let's make it b dash b. Fine. And the point from this onwards, this is YB bar. And this whole combination, this one and this one, correct, could be seen at this point, and let us mark as YSA bar. Fine. I hope you're getting the things. And now let us define the length of this step. Let's say this is LB and this is LA. Fine. Okay. Now the thing is, like here you can see that this D naught is going to be fixed, and here this D naught could be chosen as lambda by 16, lambda by 8, 3 lambda by 16, 3 lambda by 8. Yes. Okay. Fine. Okay. Now how we will do these things? This is a more or less the same problem what we have seen in a single stub matching. Correct. So let us find it out. The total input admittance at BB dash. Correct. So let us make it, this is YI bar. Fine. So how we'll define these things? The total one, this will be YI. This is not normalized one, absolute one I'm writing. YB plus YS. Means this is what? This is actually the admittance offered by the system of the first stub load and this much the transmission line. This is YB. That is why we are kept here YB. Okay. And this is parallel with this stub. So YSB. Fine. Now if I say that YI we maintain like R naught is equal to 1 upon R naught. Correct. So it means that what this could be normalized like 1 is equal to YB bar plus YSB bar. Okay. So we already have seen this kind of things earlier. Fine. Now, so this equation actually is satisfied, or indirectly if I say the solutions, correct. So the solutions will be, possible solutions are YB is equal 1 plus JB capital B. Okay. And YSB is equal to minus JB. Simple, correct? We already have seen, okay, in the last class for the singles, and you can also free to choose YB is equal 1 minus JBB and YSB is equal to plus JBB. Correct. We have seen this. So these are the two possible solution. The set of the solution. Okay. So these are the same requirement what we have seen in a single step matching. Fine. Now the next point is, so the point representing YB bar must lie on G is equal 1 circle. Fine. And the above point, this point actually, the above point should get transferred to load and means AA bar, correct, from BB bar dash to AA dash by moving on the Smith chart D naught by this is D naught by lambda. Fine. Towards load. Fine. Or if I talk about the angle movement, so this should be angle movement of 4 pi D naught over lambda in the clockwise direction. Okay. Other point you need to keep with you that the YA bar at terminal lies on the rotated G is equal 1 circle. This is important actually. Fine. And the real part of YA bar should be contributed by the real part of the load admittance, means GL. Okay. And the last point is the solution is obtained by intersection of the GL circle with the rotated G is equal 1 circle. So these are the some of the points actually. And now we'll talk about some of the steps, correct? What we need to precisely follow those steps actually. So, so before that, okay, I have some pictures for you actually. So here you can see this is a double step tuner actually. In lab, micro lab, we are using these step tuners actually, and here you can see these are the two stops actually, and here you can vary the length, correct, vary the length actually. And this is also rotating over the line, correct. This is a waveguide based, okay, and this one actually you can find in a lab also, correct. So this is a based on the single step tuner. This is a double step, this is a single step, correct. So mainly for in this lab actually, micro lab, for teaching purpose, okay. So for handling the experiments actually we are using the single step. However, we can also use the double step matching as well. This is more precise as compared to the single step. Okay, so fine. Okay, so I need one more page. Just a minute to write the steps. Okay, so these are really very important steps, and please keep with you when you are uh, drawing over the Smith chart. Correct. So it requires to do the step by step. Okay, so I'm going to write some steps actually, and you have to follow as it is. Correct. So the step number one, just a minute. So first, what we need to do, we need to draw G is equal one circle. We are already done actually in a single step matching as well. So what is this? This is where the point representing YB bar, okay, should be located. Fine. Step number two, draw this circle, means G is equal circle, G is equal to one circle. This circle rotated in counterclockwise by d naught by lambda, because where we are going to actually the load side. Okay, this is where the point representing YA bar. Okay, step number three, you need to enter YL bar as GL bar plus JBL. Okay, step four, draw G is equal GL circle, intersect, this will be intersecting the rotated G is equal 1, okay, circle at 1 or 2 points where YA bar is equal to GL plus JBA. Fine. Step number 5, mark the corresponding YB point, okay, at BB dash location on G is equal 1 circle. Means YB bar is equal 1 plus JBB. And then after you have to determine the length, okay, LA from actually angle between or the distance between the point YA and YL, and the last point you have to determine the step length for the second step at the BB dash from the angle between the point representing minus JBB and PSC, means at a short circuit point, because your steps are the short circuit. Correct. So this much work you have to perform. Okay. Now let us quickly see over the Smith chart how we can do these kind of things. Okay. Okay. So now this is the problem actually. We have a transmission line. Okay, and this is the load ZL, correct? And we are going to match these things by the double step method. Fine. And it is given to you that this is lambda by 8. Between the distance is lambda by 8. Fine. R naught is 50 ohm. ZL is given to you as 60 plus 80 J ohms. You need to find it out LA and LB. What is LB, LA and LB? This is LB and this is LA. Fine. And this is R naught and this is also R naught. So this was the requirement. This is A dash and this is B dash. Correct. So we marked all the things. What we have seen in the theory part also. Now how we will do actually? Correct. So you require a compass. Geometry box. It's very important to do on the Smith chart. Geometry box is needed. Correct. And step by step, I'll not mark today all the things. I'm expecting that you can find it out the point. You will be having the Smith chart. Okay. So first we need to here, because the load impedance is already given to you. So you can find YL bar. What is YL bar? This is 1 upon ZL. Correct. Okay, a normalized one, if you try to find it out, you have to do the things like dividing all this R naught and all. So 0.3 minus 0.4J. This is what? This is YL bar. Means if you indicate over the Smith chart, this is the location of the things. Now, okay. So not call us one, because we will go as a step what I told to you. So first step is that you have to draw G is equal 1 circle. Okay, where's the G is equal to 1 circle? I hope you remember these things. Okay, so this is the okay. This is the G is equal to 1 circle. Remember? Fine. Okay. Now, what we need to do, because uh, when I mark G is equal to 1 circle, correct? It means that where we are actually right now, we at BB dash. Okay, so we need to rotate it. Okay, this G is equal to 1 circle by lambda by 8. Okay, now the thing is to rotate lambda by 8 means step number 2 I'm talking about. Okay, so this is lambda by 8. Now if you try to find it out its corresponding angle, at what angle we need to shift it. Okay, so this will be 4 pi d naught by lambda. Now if you solve this, you will be getting 90 degree. Now how we will do, how we will take the shift of 90 degree, correct? So this is the location. Okay, and if you try to make shift it at this d is equal to 1. Okay, so at 90 degrees, so this will be like this. I can take some different color. Okay, okay, so you need to shift 90 degree. Okay, this is 0 degree and this is here 90 degree. Fine. I cannot make the perfect circle and all. Okay, this is handwritten all the things, correct? So I'm expecting that you can do, you can take the radius and diameter, whatever, you can find the point over here and you can draw a circle, correct? Fine. Now step number 3, we need to enter the point YL bar. Now, so if you find it out YL bar, okay, so I'm marking over here. So this will be somewhere here. This is 0.4, sorry, 0.3 minus 0.4J, correct? So minus, this is, if you see, this is 0.4, okay? And the circle, if you try to find it out, so this is this one, okay? So if you trace it, this is somewhere here, okay? This is somewhere here, mark it as PL. This point is PL, okay, representing what? Representing what? YL bar, okay. This is representing YL bar. Now, what we need to do actually? So right now we are at the load location, correct? And better to mark GL circle, okay? Better to mark the GL circle. What is GL? GL is actually this value, okay? So this is GL. So GL is 0.3. So we need to mark the 0.3 wala circle, okay? So 0.3 circle, if you try to find it out, so this is 0.2, 0.3, okay? So if you trace this thing, so this will be like this. This green color I'm drawing here, okay? Okay, this is what? This green circle is GL is equal 0.3, okay? Now, if you recall your steps, correct? So, what I told, these things, it will be going to cut at the 2 points, okay? So, what are these 2 points? So, first point is this, okay? And the second point is this on rotated circle, okay? So, rotated circle means we are at BB dash. Oh, sorry, this load location actually, fine. So because we are at load location, so what we can say, this is these 2 points representing as PA1 and this is PA2, fine. We have 2 points, correct? We have 2 points. So step number 4, we need to read it PA1. So if you find it out, PA1 corresponding YA1, this will be 0.3 plus 0.29J. Please try on the split chart. And PA2, if you read it out, this is YA bar 2 is equal to 0.3 plus 1.75J. Okay. So now you have the 2 points, correct? Now, what is next actually? So I'm going to remove this thing. So I'll do all the things over here only. Fine. Now, so what is the next step actually? Now these 2 points representing YA1 and YA2 normalized one. Okay, fine. Why this is YA1 and YA2? Because this is on rotated circle. Okay, and this rotated circle came from G is equal to 1 circle, and G is equal to 1 circle. It means that earlier, if you talk about the G is equal to 1 circle, it means we are at the point BB dash. And when we are rotating by 90 degree, we reached at AA dash, which is a load location. Fine. Now, if you move over the GL is equal to 1 circle and it is going to intersect, it will provide you the YA1 and YA2. Correct. Now, the next point is the step number 5. What you need to do? You need to use your compass and consider this point O, okay, the center point, and you have to take this much radius, okay, and you need to translate this point over the G is equal to 1 circle. So you will be at BB dash, okay. So when you are translating this point, so it will be going to cut, okay, somewhere uh, on G is equal to 1 circle at 2 points actually, okay. So if you taking this radius, so this will be like this, somewhere here. And if you are taking this radius, it will be somewhere here. These will be the 2 points, and let us mark it PB1 and this is PB2, correct? Now read it these 2 points, okay, read it these 2 points over the G is equal to 1 circle, fine. So if you read it these things, so you can find it out. YB1 is 1 plus 1.38 J, and YB2 corresponding to PB2 point, and this is PA1 PB1 point. So this will be what? 1 minus 3.5j. Fine. Now you have all the points actually. YB1, YB2, YA1, YA2. Correct. Now what we need to find it out? We need to find YSA and YSB. What is this? This is the admittance of a step, huh, for A and B, first and second. Okay. So let us talk about the first one first. Okay. So I can remove these things. Okay, please note it down all these things somewhere, because we are doing over the Smith chart here, so I cannot draw again and again. So I have to remove. Okay. So the step number 6 will be, you have to find it out YSA bar 1. So this will be what? YA1 minus YL bar. Now if you try to find it out this thing, because you have all those things, correct? So this will be 0.69J. Find similarly YSA2, if you find it out, this is J1 2.15. Okay, what is this? This is point A1, this is point A2. Okay, means this point A. Fine. These are the two possible solutions. That is why A1 and A2 I am writing here. Fine. Now how you will find it out? LA1, first possible solutions. Okay, first possible solutions means for A1, if I'm writing here, okay, so what we need to do, we need to move PSC. Okay, where is the PSC point? The PSC point is this short circuit. Why short circuit? Because here we have a short circuit. So from short circuit you have to move from this point. Okay, so PSC2 you have to move A1 or A point. So LA1 will be point, you have to read it, these things. Okay, 0.096 plus 0.25 lambda. So this will be 0.346 lambda. Fine. Okay. So you need to find it out, these things uh, uh, corresponding values actually at A1 and A2. You need to mark this A1 and A2 over here. Fine. So you have to find it out, these things. And if you talk about the LA2, so you have to move from PSC to A2. And if you try to find it out, this A2 and PSC, so you can read the scale, and this will be 181 plus 0.25 lambda. This will be 0.341 lambda. So this is the second solution. So now you have the two solutions. One is this first solution, and this is the second solution. Fine. What is this actually? This is the length of the first step. In a similar way, you can do for the second one. Okay, I should remove this thing, so I'll do over here. Now, so this is the point A, correct? Means at this point, now we have to do the calculation at BB dash. Why? Because we are now interested in LB. Fine. So we already have a very good background of the single step this thing, and I already told you the solutions and all, correct? So can we find it out YSB1 and YSB2? Yes, of course we can find it out, because we have already seen the solutions. Okay, the solutions for PB1 and PB2 point. Okay, it was YB1 as 1 plus 1.38J and 1 minus 3.5J. So corresponding to these points actually, you can easily write, because this will be Means if there is a plus, you have to take the minus sign in our imaginary part. Okay, so the if I'm talking about YSB1, okay, so what is YB1? It was 1 plus 1.38J. So YSB1 means this is minus J 1.38. Correct? Because we need to normalize it like that. This would be a solution. So this addition will be 1. Similarly, YSB2. Okay. So this was earlier 1 minus 3.5J. This is YB2. So here this will be plus 3.5J. Now everything will same actually. So if you try to find it out LB1, so LB1 is nothing but the distance between PSC, means P short circuit, because this is ultimately short circuit. Okay, steps are short circuit. So you need to move from PSC to B1 point. Okay, so if you try to solve it, these things, okay, so this will be 0.35, okay, minus 0.25 lambda. This will be 0.10 lambda, and LB2 will be PSC to B2. Now, if you solve this, you will be getting 0.456 lambda. Fine. Now, I actually skipped some of the points here. What these corresponding to these admittance, okay, you need to perfectly find it out, precisely find it out the points on the concerned scale, correct, where you're moving the towards the generator, towards the load and all the things. You need to find it out. Fine. And you need to mark it properly over the Smith chart. Correct. So once you have the point, now you have to, you know that where you are moving, you are going from short circuit to the point A, or short circuit to point B. So easily you can, on the basis of situation, you have to subtract or add. Okay, and you will get the correct length. So in this way, what we have seen, that we can solve actually for particularly we can find the different lengths, and we can match the overall circuit by using the double step method. Correct. So this is the thing actually, and similarly some other things you can find it out. Sorry. Okay. So like the triple step, you can see also. However, this is not actually the part of these things, but you can see. And apart from this, actually the Smith chart, because sometimes the calculation is not uh, very bulky and all the things, correct. So there is a provision that we can also derive some formula, and by this formula you can find it out, this LA, L1, LB, LB1, LB2, like that. So in DM Pozar book you can find it out, these derivations, correct. So these are the analytical approach, and you can see actually, correct, you can see, and you can you can solve with those analytical formula, that how you can find it out the different lengths. Okay, so this is all about this double step matching, correct. So if you have any questions, you may ask.